Hey there, everyone. In today's teaching lesson, we are going to review recommendation systems and compare and contrast a bunch of different recommendation system methodologies. Okay, so there's two main types. There's collaborative filtering. This is where recommendations are based on basically preferences and behaviors of similar users. So if I like something, and I know my friend likes the same type of thing, I would recommend that to him. So movie recommendations is one of the top things that comes to mind. Music recommendations, product recommendations for e-commerce sites, things such as this. Basically, it's based on the concept that if a user likes something and you have a friend that has similar tastes, the friend will like it too, right? So content-based filtering is a little bit different. This is based on the features or the attributes of the product. So if similar products have similar features, you could recommend one product because you know that you already like another type of product. So one would be probably Coke and Pepsi. If you like Pepsi, you probably like Coke. If you don't like Pepsi, you probably won't like Coke, right? That's an example of that. So it's more like the feature, the taste, specific attributes or features of the of the product or service. So movie recommendations based on genre, actor, and director. That wouldn't be an example. So not the movie per se, but the type of movie and who stars in the movie. Things like article recommendations. If you like the writing style of Wall Street Journal articles, you'll probably like The Economist and vice versa. Product recommendations based on product attributes or features, things like that, right? So there's collaborative filtering, which tries to make recommendations based on products, movies, users, preferences, based on the preference or the behavior of similar users, right? So users will have similar behaviors. If they do, then they'll like the same types of things. There's user-based collaborative filtering, where items are identified that have similar preferences, and those are recommended specific to each other or relative to each other. And then item-based collaborative filtering is when recommendations are done based on identifying similar items and you suggest items that user has liked in the past. Okay, so those are the types of examples that we're discussing today. This should sound familiar. You've probably seen this. Netflix movie recommendations, Amazon product recommendations, they all use the same type of concept, right? This is recommendation engines. So let's look at an example of user-based collaborative filtering. I have usernames and product names, and then I have users, products, and ratings. And if you're paying close attention here, you're seeing that I'm actually generating some data dynamically. I don't have these item recommendations. I don't have Amazon reviews right now. I could go get it, but the web is a dynamic place. It's going to change over time. I don't want to go and copy and paste those down, so I'm just going to generate my own data just for argument's sake here and to illustrate the point of what we're trying to do. So let's see, we have username, product name, user, product, and rating. Okay, and I am going to get the user recommendation. I have a function that's defined as get user recommendation. I want the top 5 recommendations based on user ratings, okay, and the weightings of each rating. Okay, so a higher weighting is going to indicate more sensitivity, more importance for that product, right? And lower weighting is going to have less influence, less importance, right? So I'm going to go ahead and hit Control Enter to refresh the logic in this cell. Okay, the code will run and it's going to print the top recommendations for us. In just a moment, I'm going to share all this code with you. When I post a video, I'll post the code so you have everything, including all the business logic, all the comments and everything that you need. So you don't have to worry about all the details now. You'll have this when you download the file and double click it to open it. You'll have an HTML file that contains everything that you see right here. Okay, so the top recommendations for this user, Alice, would be conditioner, kitchen tools, and mouthwash. Okay, so we have the top recommendations based on what a friend of Alice was buying. The friends suggested to Alice, I bought these items, I think you'll like these, and these go together, right? If you think about it, conditioner for your hair, kitchen towels, and mouthwash, these products are somewhat similar, right? If you are running out of any one of them, you might go ahead and just buy all 3 just to replenish your supply of these items, right? So the recommendations for user are based on collaborative filtering, right? And we use cosine similarity. I've discussed this in a couple of my videos. Cosine similarity is a very useful methodology to look at similarities of different types of texts, right? Or even sentences, paragraphs, bodies of text. You can compare the similarities of different types of text at many different levels and different degrees and different lengths of text too, right? So dense or sparse or whatever you want. So these three go together: kitchen, towels, conditioner, and mouthwash. This example of collaborative filtering using cosine similarity. Now the collaborative filtering has made a recommendation for us, and I think this makes sense. This is relevant. This is important. I think this is working. So let's move on, okay? In the next example here, we have item-based collaborative filtering, right? So a little bit different approach to filtering. Again, I'm generating the data dynamically here. So we have usernames, product names, users, products, and ratings, right? We're creating a data frame to merge all that data together. Once it's blended together, we're going to get item recommendations. Now, this is not what your friend likes, and you and your friend have a lot of things in common, so you're going to recommend these things to your friend, right? This is based on the features or the attributes of the product itself, right? So products that have similar features are going to get recommended. If you like one product, you're probably going to like a similar type of product that is a different brand, slightly different marketing, slightly different product or whatever it is, right? But if you like one thing and it's similar to a different thing, you're probably going to like this, right? So based on the item recommended for Alice, we are going to get soap. Okay, so I think it's working. Again, we set up the recommendation engine and it produced the result. Soap is the recommended product for Alice to buy. Okay, so let's move down a little bit further as some more notes. Collaborative filtering is based on similarity between items. Again, not what your friend likes, but which items are the most similar. You're going to recommend those. If you liked another item that's highly similar to this one in the past, you probably like this brand new item. You've never tried it before. So let's take a gamble and try this thing out and see if we like it. Bear with me. I just saw some text going off the screen. Let me fix that so we can see everything. Okay, there. Now we can read it. Okay, content-based filtering is useful for attributes or features of the product, right? And the user's preferences. It's different from collaborative filtering because it focuses on the characteristics of the product. So let's look at one more example here. Now we have movie titles and genres. We're going to, again, dynamically generate this data because I don't have access to this data. Some things I do, some things I don't, and this one I don't. So let's go ahead and run it. So we have our data frame that contains movies, titles, and genres of movies, right? And user preferences. We know it's action movie, adventure, drama, sci-fi, comedy, and romance. Okay. And again, we have TF-IDF working and cosine similarity. So you'll see these topics come up over and over. I've discussed these in some of my other videos. Very useful, very practical to understand text. The computer can't really understand words very well, right? But once you convert the text into a vector, which is basically just numbers, you're assigning numbers to the characters of strings or characters of words, right? Once it's in a number format or some type of numeric format, then the computer can understand very quickly and easily what's going on. It's not going to understand words and text like humans do, right? But once you convert that into some type of vectorized numeric representation of those words, then the computer can deal with it. So that's what we're doing here. And based on this recommendation, we have, if you like movie A, you'll probably like movie C. There's 36% chance that you'll like movie C. B and D, 0 chance, right? So if you like movie A, that is an action movie. We'll recommend movie C. That looks like A, B, C. That's a drama, okay? But B and D are off the table. This is adventure, and D looks like it's a romance, right? So if you like action, you're gonna like drama. You don't like adventure, and you don't like romance. I think that makes sense. So I think this is working. Let me see what's down here. Yeah, I think that's pretty much it, guys. I have some notes. TF-IDF vectorization, just describing how that process works, cosine similarity. So I have to find that and give some more context and enriched the meaning of that. and the recommendation functions, and then the result explanation. So we went over that. These are my notes here at the bottom. So that is pretty much it. We have a couple more use cases down here. For deep learning recommendations, that's another way to create a recommendation engine. We have association rule mining, matrix factorization. These are a little bit more abstract, obscure ways of doing recommendations, but the ones that I described above here, these are the more common ways, but there are some more, I guess, less popular ways to do these types of things. Probably the outcome isn't as accurate, and maybe the takeaway isn't as meaningful or substantial too, but yeah, the topics that we discussed in the video today are probably the most relevant. So there you have it. Hopefully you learned a couple new tricks, at least one new thing. Hopefully I try to learn at least one new thing every single day. Hopefully you do too. Thank you so much for your time today. And as always, have a wonderful rest of your day. Thank you, everybody. Goodbye.